Hello, hi. You're welcome to today's class. I'm glad to be here again. This is another Tuesday. I would want you to share this link or this status to every of your friends, your family, so that they can join this live class. I promise you it's going to be life-changing, okay? So we are going to start from where I mentioned, I already announced, which is X-rays. And so we are going to start with X-rays. Now, what is X-rays? X-rays, first of all, is an electromagnetic wave. That's the first thing you should know about X-ray. Electromagnetic waves. Okay? What we understand about electromagnetic waves is that they are waves that require material, that do not require a material medium for propagation. They don't need any material, to move. There are actually 7 of them, 7 electromagnetic waves. We have visible ray, we have microwave, we have radio wave, we have infrared rays, we have gamma rays, we have UV rays, we have visible rays. There are about seven of them. Okay, so X-ray is an electromagnetic wave. Okay, now with the following characteristics. The first thing I want you to note about an X-ray is that it has a very short wavelength. Very short wavelength. Then number 2 is that it has a very high frequency. It has a very high frequency. Then the third thing you need to know again is that it has a high energy. So whenever you hear of an electromagnetic wave that has short wavelength, high frequency, and high energy, it means you are talking about X-ray. Now, another electromagnetic wave that falls into this category is actually gamma ray. I know some of you have heard of gamma ray. One of these days, I will be teaching that. Okay, gamma rays are also electromagnetic waves. They have very short wavelength. They have very high frequency, and they have high energy. Later, I'm going to tell us the implications for all of this. Okay, don't forget that if you have any questions, feel free to ask. I'm going to be here with us to see your questions, okay? Now, the next thing I like to talk about very quickly is what I call the properties of an X-ray. What is the properties of an X-ray? Now, X-ray has certain properties. Before we talk about how X-ray are formed, I want to quickly talk about the properties of X-ray. Now, amazingly, in the definition, we already have some properties. Number 1, they are electromagnetic waves. They have very short wavelength. They have high frequency, and they also have high energy. They are highly energetic. But there are other properties that we can list here. Okay? One of such properties is that they travel in a straight line. They travel in a straight line. Sometime, I think that was last Tuesday or last 2 Tuesdays, we talked about cathode rays. Cathode rays also travel in a straight line. But one of the things that differentiates a cathode ray from an X-ray is that an X-ray is an electromagnetic wave, but cathode rays are electrons. Don't forget that. I don't want us to forget that. X-rays are electromagnetic waves, X-rays are electromagnetic waves, but cathode rays are simply electrons. So one of them is that they travel in a straight line. Can you see that? Now, another is that they have high penetrating power. They have high penetrating power. As a matter of fact, that's the reason why X-rays are used to view bones, because they can penetrate through the skin, but there are some materials they cannot penetrate through. For example, bones and something like lead, they can't, that means you can stop it. X-ray can be stopped using either bones or lead. I believe that makes sense. Now, another property, of X-ray is that they are, I've mentioned the fact that they are highly energetic. That's important to know. Another property of X-ray is that they have high ionizing power. Not really high, but they can ionize gases. They can ionize gases, maybe not necessarily high. Then number 4, they can also, just like cathode rays can also ionize gases. Number 4, they can cause some substance to fluoresce. Some substance to fluoresce. In the last class, I already explained what it means to fluoresce. To fluoresce means to glow, to show light, and the rest of them. That is very, very, very important. I don't want to forget. Now, another thing I would like to mention is that they can affect photographic film. They can affect photographic film. If you have ever been to an hospital before to have an X-ray of your body or maybe of a broken bone, there is this film where you see it being placed. That is what a photographic film is. So an X-ray can influence a photographic film. That is very, very important. Another thing I like to mention about X-ray is that number 6, this is very important. They travel with the speed of light. And of course, you know the speed of light. The speed of light is 3 × 10⁸ meters per second. That is the speed of light. Okay, that is very, very important for you to note. Now, I want to say this, that all electromagnetic waves, all of them, the 7 of them, travel with the same speed of light, which is 3 × 10⁸. Kindly note that. Another property of X-ray is that they have wave property. They have wave properties. When we say waves, wave property means that they can exhibit reflection, refraction, diffraction, and all of that. Why? Because it is an electromagnetic wave. X-ray is a wave. Very, very, very important. Now, another one I want you to notice, X-ray does not have any charge. If you remember, when we treated cathode rays, we said that cathode rays are negatively charged. But in the case of X-ray, it is different. X-ray has no charge. That means they are not deflected in magnetic or electric field. They are not deflected in magnetic or electric field. That means X-rays are not influenced by electric or magnetic field. They are neutral. I am comparing with cathode rays because sometimes in exam questions, they look alike and you may go and tick something about cathode rays for X-rays. So you should know the difference. There are certain things there that are not cathode ray. Cathode ray can be deflected by magnetic and electric field, but X-ray cannot be deflected by magnetic and electric field. Okay, let me quickly watch who is commenting. If you have any questions, you can drop. Okay, I like the fact that some persons are here already. Okay, so that is it for the properties of X-rays. Remember, like I said, you can share. Remind your friends that classes have started. Let them join in. They would have a lot to learn. So I'm going to move quickly to the next thing, production of X-rays. How are X-rays produced? Okay, X-rays is quite very, very important. Has a lot of uses. That's one of the reasons why we are studying it. So the question now is, how are X-rays produced? So like I've always said, I'm going to be leaving the video here for some time, so you can always watch it. Okay, so the next is how X-rays are formed. Now, there is what we call the X-ray tube. That is where X-rays are produced. Sorry, I don't know how This is a tube. You can call it a vacuum. Okay? And you have anode. This is where you heat. Then you have a cathode this way, which is made up of copper. But in this cathode, you have something like this. We call this the metal target. Okay? We call this the metal target. This metal target is especially tungsten. In case you are asked, it's usually tungsten. Okay? Now, and definitely both the anode and the cathode, this copper here is the cathode. Oh no, is the anode, sorry. The cathode is always where the heat is coming from. Remember, cathode rays. Okay, so this is the cathode. So automatically we can actually say that X-rays are produced from cathode rays because the process starts with cathode rays, and I will explain. So there is a connection from here, and there's a connection from here, which shows, this connection shows a high voltage. Okay, so let me give you the process, because this is an exam question. This is it. Now, this high voltage, the reason is to supply current at high voltage. The purpose for the high voltage is so that this cathode can be heated. So this cathode is going to be heated. I want to say something here that there should be something like this here. These ones here are called cooling fins. No, not here. Sorry. I'm going to put the cooling fins here. So these are cooling. Okay, so these are cooling fins. Now this is what happens. After a high voltage is being supplied, this cathode ray becomes hot. Remember, all of this stems from thermionic emission, meaning the emission of electrons because of heating a surface or heating a metal. So this cathode is heated, becomes very hot, and start emitting electrons. Now those electrons it emits now travel from the cathode to the anode, and they are going to hit this tungsten, this target metal. Now once they hit the target metal, that's how X-rays are produced. You are now going to see X-rays like this. You are going to see X-rays like this. You are going to see X-rays like this. This is X-rays. This is X-rays. So we can actually say that X-ray is a product of secondary emission. Secondary because the primary is the emission of cathode rays. Then from cathode rays hitting the target, then from the target you see X-rays are produced. Now I want to also say this for exam purposes. It is not only X-rays that is produced. As a matter of fact, it is 1% of X-ray energy that is converted to X-ray. The remaining 99% is heat. So heat is also produced in this process. And heat, the production of heat in this process is 99%. And I want to say this, and for you to understand this, I want to say this, that these cooling fins, this is why it exists. So that the heat that is generated, the cooling fins can take care of it. Now, there is this exam question that is very common about the kind of energy transformation that happens here. You can see that the first energy that happens here is electrical energy. Electrical energy. That means supplying of high voltage. From electrical energy, it is converted to heat energy. The heat energy is what produces the cathode rays. Can you see that? From the heat energy, it moves to kinetic energy. You're going to wonder, what is kinetic energy? Because the cathode rays gain speed. The cathode rays that are emitted from here gain speed and move straight towards the target. So that is electrical energy. Then from electrical energy, finally now to electromagnetic energy. You can say electromagnetic and heat energy. Because the process, the final production is X-rays and heat. And like I said, the energy conversion here is from kinetic energy to electromagnetic and heat energy. X-rays produce just 1%. Heat energy is the remaining 99%. But we don't need heat. So that's why these cooling fins will take care of the heat. Am I making sense? I believe that makes sense. And if you are understanding, kindly kindly note or state that you are following what I'm doing, okay? So this is very important. we are going to see some past questions, and you will see why this is important. I think I've made some things quite easy for you here. Okay, so that leads us to the next thing. Let me give you 1 minute to maybe swallow what I just taught now, just 1 minute. We are doing well. Okay, I can see a lot of people are trying to join. Okay, so I'm going to rub this off. Let us go to the next thing. Okay, so don't forget about it. This is one of the main things when we are dealing with X-ray. Okay. Okay, very good. Now, the next thing we are going to consider is what we call, we've done properties of X-ray, we've done the formation of X-ray. The next thing is types of X-rays. Types of X-rays. Now, there are basically two types of X-rays. There are basically two types of X-rays. One of them, the first one is called soft X-ray, and the other one is called soft hard X-ray. So two kinds of X-rays exist. One of them is called soft X-ray, and while the other one is called hard X-ray. And you should notice something. When you say soft X-ray, both of them have the similar properties, but just that one is milder than the other. For example, between these two in comparison, you can compare these two. Between these two in comparison, the soft X-ray, number one, is that it has a longer wavelength. Longer wavelength. When I say longer wavelength, in comparison to hard X-ray, okay, it has shorter frequency. I can also say that when you say shorter frequency, you can say lower frequency. It has a lower penetrating power. As a matter of fact, if you're asked to define soft X-ray, you should say that it is X-ray with a lower penetrating power compared to hard ray. So even though hard ray has a higher penetrating power, remember this is in comparison to this. Both of them are X-rays, but one of them is milder than the other, and while the one is harder than the other. So lower penetrating power. Another I will mention is that as a result of lower accelerating voltage, say lower accelerating voltage, then I think that would be it for now. I already mentioned that it has lower energy compared to. So I don't need to say much here. That means if soft X-rays have these properties, then you know what hard X-ray would have. That means hard X-ray will have longer wavelength, would have higher frequency, would have higher penetrating power, would have higher accelerating voltage, okay? Then we'll also have lower energy. That is very, very, very important. I believe that makes a lot of sense. Okay. So that leads us to the next thing. And I would like to say this quickly, that when you, the soft X-ray has its own major uses, and the hard X-ray also has major uses. Okay, for example, the soft X-ray, we use it in like mammography, like in analyzing breast cancer, dermatology, skin treatment, crystallography of organic molecules, you know. But in cases like chest bone X-rays, you need a hard X-ray in that case, CT scans, cancer radiotherapy, that's destroying tumors, industrial NDT of metal woods, you need hard X-ray. So there are some cases where soft X-ray is needed, and there are some cases where hard X-ray is needed. But what is most important, especially towards your exams, should be the comparison between a soft X-ray and a hard X-ray. Okay, that is very, very important. Okay, so that leads us to the uses of X-ray. I'm going to mention some of them. I will just write some of them. Okay, one of the uses of X-ray is for medical diagnosis. Medical diagnosis. Now, this medical diagnosis, we call it radiography. Okay, so you can use it to check for broken bones, because X-ray can actually pass through our skins, and when they pass through our skin, they can use it to view bones. I remember one of the days I went to the hospital to go check my tooth. They had to put me between an X-ray, and so I saw my tooth. I could see the defect in my tooth from the X-ray. That is what we call radiography. So the shadow cast on the film or detector reveals fractures, dislocations, and the rest of them. Now another, that's what radiography is. Okay, diagnosis, checking your bones, checking for cracks in your bones, and all of that. Now the second important use for X-ray is that it is used for medical treatment. X-ray can also be used for medical treatment. In this case here, we call it radiotherapy. And when we say radiotherapy, you should know that X-rays can also be used to destroy cancerous cells. Yes, you can direct X-rays to cancerous cells, especially cancerous cells that are just developing. You can direct X-rays to cancerous cells and it is destroyed. That is what we call radiotherapy. That's an important use of X-ray. Another important use of X-ray is what we call industrial. Okay, let me just put it this way: checking for defects. Checking for defects in metal pipes. In metal pipes and artifacts. So we can also use X-rays to check for defects in metal pipes and artifacts. Another one, number 4, is what we call crystallography. Now, from the word crystallography, you should know crystallography comes from the word crystals. That means you can use X-rays to check the structure of crystal. It's an important aspect in chemistry, you know. Then another is for scientific research. I will just add that here, scientific research. So there are a lot of scientific research, material science, biology, and all of that X-ray can be used for, and some others that you can always check out for. That is very, very important. Okay, so that is it for the uses of X-ray. We are going to go through some past questions together to see the kind of questions that are asked here. Now, but because of time, we move to the last thing, and which is calculations. So we want to look at calculations involving X-rays. And the first calculation, the first thing I'd like us to note here, well, I hope you are done writing. Okay, let me give us some seconds to write this. Okay. So some seconds to write this. Now this is very important. When you start seeing past questions, you will appreciate, what we are doing. Okay. So that leads us to the next thing. And don't forget that if you have questions, you can post your questions. I will be seeing them here. Can I remove? I think so. Okay, so the next thing we are going to be looking at is calculations involving X-rays. Now, there are two calculations, two important formulas that I want you to note. One of them is what we call the energy of electrons. I think when we did photoelectric effect, I gave us certain formulas for energy of electrons, and any of them can be used. The first formula I gave you is that we know generally kinetic energy is half mv squared. You shouldn't forget that. But most importantly, that kinetic energy can also be electron volts. Kinetic energy can also be electron volts. You remember, E here stands for the charge of an electron. V here stands for the stopping potential, if you can remember that. Now, but I want to also say this, that the second thing to note here is what we call energy of photon, X-ray photon. X-ray is also a type of photon. Now, the energy of photon is simply, let me write here, Ke. The energy of photon is simply E is equal to Hf, as simple as that. Now, you can either say Hf or you simply say Hc over lambda. The same formulas you know, will I say close to the same formulas you know in photoelectric effect, but the calculations here are quite different. So there are cases now, but because there's an energy conversion from kinetic energy to X-ray energy, it is right if we equate any of these equations. That means sometimes you can present it like this: half mv squared is equal to Hf. Kinetic energy being converted to X-ray energy, electromagnetic energy. Sometimes you can have electron volt is equal to Hf. If you know this formula and know this, then you can solve any question involving X-ray. And don't forget that F can also be c over lambda, speed of light divided by wavelength. Don't forget that. Okay, I'd like you to write that before we see questions. Okay, while you are writing it, let me write some questions by the side here. I have a question here. It says, okay, number one, it says, okay, we have a question here. Looks like a very interesting question. So let us solve this question. Life is beautiful. Okay, this is a life-changing question. So let me clean here up. And let's see. Now listen. It says, an electron is accelerated through a potential difference of 40 kilovolts. That's potential difference, which we used to call stopping potential. So the potential difference is 40 kilovolts. Now in physics, you should know that kilo means 1,000. So I can still call this 40,000 volts. Okay, so 40,000 volts. And it says calculate A, its kinetic energy in joules. Why should this be difficult to calculate? I already showed us that. Now, the kinetic energy, like I said, the formula to use here, since we are given the potential difference, the formula to use here is simply EV, as simple as possible, where E is the charge of an electron and V is the potential difference, as simple as that. Now, the E here, charge of an electron, is a constant value. Anywhere, in Nigeria, in the US, anywhere, it has a constant value. The constant value is 1.6 times 10 to the power minus 19. That's the value for E, the charge of an electron. Then multiplied by V, potential difference here is 40,000. So if you multiply this now, it's going to give us 6.4 times 10 to the power negative 15 joules. So this is the value. We just answered this first question. It's kinetic energy in joules. And we can see here that it is 6.4 times 10 to the power minus 15 joules. As easy as that. You shouldn't fail questions like this. Now look at the next question. It says the minimum wavelength. Now it's looking for wavelength. The minimum wavelength of the X-ray produced. If I need to find wavelength, and I know we are talking of X-ray here, then I can use that this energy now, which is 6.4 times 10 to the power minus 15, this kinetic energy, convert it to X-ray, which is, in this case, we are going to use HC over lambda. Why are we using HC over lambda? Because we are asked to find wavelength. If we were asked to find frequency, we would have just said HF, and that is that. So now we want to solve for wavelength. Now don't forget that H is called Planck's constant. It has a constant value. C is called the speed of light. It has a constant value. If you're a science student, you should know some of these things. These are constants, okay? So if I substitute the values now, this is going to be 6.4 times 10 to the power negative 5 is equal to your H is 6.63 times 10 to the power minus 34. It is constant in Bangladesh, in China, in any country you go to. Planck's constant has the same value, which is 6.63 times 10 to the power negative 34. Then speed of light is also a constant value, which is 3 times 10 raised to the power 8. So these are values that sometimes in your exams you will be given, but even when you are not given, you should know. Okay, then everything divided by the wavelength. Now you can apply your mathematics here. By cross multiplication, you can find the wavelength. We can say that wavelength is equal to 6.63 times 10 to the power negative 34 times 3 times 10 raised to the power 8 divided by 6.4 times 10 to the power minus 5. So here you can now use your calculator. And if I use my calculator, you can multiply the numerator and divide by the denominator. And the answer is 3.11 times 10 raised to the power minus 11 meters. Meters is the unit for wavelength. So this is how to solve a question like this, which I believe makes a lot of sense. Right? Makes a lot of sense. This is the point where I say, and your life begins to change. Okay? So I like you to write that. I'm going to give you some few seconds to process that before we move to the next thing. Okay. Okay. Okay, somebody's asking, do we have to convert kilovolts to volts whenever we are solving? Yes. Kilovolt is not an SI unit, so you have to convert it. Okay? Whenever you're solving. It's just the same thing as kilojoules. You have to convert it to joules. You know, kilo is just a sub-unit. Yeah, we can call that a sub-unit. So you must represent it by 1,000. Okay. Any other question? Yes, you always have to convert kilovolts to volts. And it doesn't have to be kilo, it can be anything, it can be megavolts. Mega means 1 million, 10 raised to the power 6. It can be millivolts, millivolts. Milli means 10 raised to power 3 volts. You know, it can be anything. It can be nanovolts. Nano means 10 raised to power -9. Sorry, milli is 10 to power -3 volts. It can be microvolts, that is 10 raised to power -6 volts. So you need to know some of these subunits. It's very important. Always learn the subunits. In one of our classes, I'm going to show you people how to recognize subunits. Okay. Yeah. For those liking the videos, thank you. Thank you for liking. Thank you for sharing. God bless you. So I want us to solve another question here. A very quick one. I believe you're done writing this. Let me write it here again. So this one says, okay, this is another one. Okay. Let me also add here. C. Okay, so I'm going to solve just 3 questions, and I'll be posting the rest on the group, so you can find yourself in the group. I will post all the details. If you are just joining, we have a group, a live class. That is where I post more questions for practice. You know, remember, 300 is the goal. Do we have any question here? I can't see any. Okay, so I think I should rub this off now. Let me put this here. Don't forget the name, Life Changer Academy. I remain Mr. Life Changer, you know, but I'm not the only life changer though. We have a lot of life changing tutors, you know, with us. But I am the face of Life Changer Academy. Okay, so look at this question. It says X-ray has a frequency of this. Here we are given the frequency of an X-ray. And the frequency of the X-ray is 3 times 10 raised to power 18 hertz. We should write that down. It says calculate the energy of each photon in joules. So we are looking for the energy of the X-ray. X-ray is also a photon. And they said we should also calculate the energy in electron volts. Okay? That's also very easy. Now the energy in joules, remember the formula for energy, the same thing with light, it is HF. Very simple. H here is Planck's constant, like I told you, is a constant value. Then F here is frequency. So if I substitute the values, this will be 6.63 times 10 to the power -34. Then multiply by the frequency, this is the value for frequency, 3 times 10 to the power 18. And that would give us the answer. Okay, so what I have here, if I use my calculator, my answer here is 1.989 times 10 to the power -15 joules. Okay, so this is the energy of photon. Very simple. This is a very straightforward question because we're asked to find the energy of the photon. Now, but the second question says we should find the energy in electron volts. I already told you something, that the energy of electron is measured in joules, but it is also measured in electron volts. The same thing with photon energy, you know. And for you to convert energy from joules to electron volts, you divide by 1.6 times 10 to the power negative 19. That's the deal. So it means that this energy now, to convert it to electron volts, I would say 1.989 times 10 raised to the power negative 15 divided by 1.6 times 10 raised to the power negative 19. Okay? And that will give us the value. So the answer here is 12,431 electron volts as the answer. Quite straightforward, which we can also write as 12.4 kilovolts. Kilo electron volts. That's beautiful. Kilo electron volts. That is beautiful. Okay, but I also want to say something here, that this 12.4 kilo electron volts, this 12,431 electron volts, if I was asked to find the potential difference, the answer would be 12,431 volts. That means without the electron. So I can put here that the potential difference is simply 12,431 volts without the electron. I explained this in our last class, and this is me explaining that here again. Okay, this is beautiful. This is beautiful. Are we not done with a lot of questions? Maybe I should do one more. Okay. I think a question is remaining. The velocity of the electron. If you already know the energy, the velocity of the electron should not be a problem. And please note this for those of you that are serious to learn. Remember that the energy here, or will I say the energy here in joules, is 1.989 times 10 to the power negative 15. If I'm asked to find velocity, that means I will equate this energy value to half mv squared, which is formula for kinetic energy. Yeah, you equate it to half mv squared. And at this point, let me help you here. There is a general formula we can use here. In case you encounter a question, let me prove it quickly. When you have half mv squared to be equal to electron, let's not use electron volts. Yes, to be equal to electron volts, we can use this too. You know the value of electrons, and this volt is potential difference. We can say that half mv all squared is equal to mass times electron volts. mv, oh, don't worry about this. I will show you when we would use this. Don't bother. So let's just find the velocity here. It means that 1.989 times 10 to the power negative 15 is equal to half times. Now m is mass of an electron. Remember, half mv squared is the kinetic energy of an electron. And the mass of an electron is also a constant value. It's a constant value. You should know, as a science student, you should know the value for the mass of an electron. You should also know the value for the charge of an electron. So the mass of an electron is this. Mass of an electron is 9.1 times 10 to the power negative 31 kilogram. That's the mass. The charge of an electron is 1.6 times 10 to the power minus 19 coulomb. It's a constant value anywhere you find it, okay? It does not change. Even if you have to travel out for your WAEC, it's still the same value. Or you have to travel out to another country, it's still the same value. Okay, so I'm going to write here 9.1 times 10 to the power negative 31. Then we have v squared. So we can make v squared the subject of the formula here. That means v squared would be 1.989 times 10 to the power negative 15 times 2 by cross multiplication divided by 9.1 times 10 to the power negative 31. So here we can now find V. The velocity now is going to be square root of 1.989 times 10 to the power negative 15 times 2 divided by 9.1 times 10 to the power negative 31. That is very important for you to note. Don't forget. Okay? That's important. Now you can use your calculator. Maybe let me use my calculator here to get the value quickly. Okay. Okay, so the value is 6.61 times 10 raised to power 7. 10 to the power 7 meter per second. That's the value. So you can write that down. Okay. Oh, thank you everybody for commenting. Now somebody asks, is this basically all the units needed to solve questions on X-ray? Yes. That's why you need a teacher like me to show you something like this. Yes, that's all you need. That's all you need. And is this all the units we need to solve, like Planck's constants and the rest? Yes, this is all you need. The only formula you need is what I have written. And let me write them again. For X-ray, the formula is that the energy is HF, or you can say HC over lambda. Then the kinetic energy is always electron times potential difference, and which can also be half mv squared. So you can equate any of them. You can equate them and solve any question of your choice. Anywhere you see an X-ray question, you can solve it. Oh, I love this. I love this. Yeah, I will also want to use this opportunity to tell those of us that are interested in joining my online classes. And we do an online class, me and some of my teachers, we do an online classes every day, Mondays to Saturdays, 8 p.m. to 10 p.m. You know, for those preparing for JAMB, you're preparing for WAEC, you're preparing for NECO, you know, that is going to help you brush you up. For those writing JAMB, you have about a month to do a very heated, you know, classes. For those writing WAEC and NECO, you have about 2 to 3 months, you know, to do very well. So take the most of this opportunity, and it is just for 20,000 naira. So you can, my number is on the screen. You can just send me a message on WhatsApp that you are interested in joining, and we would add you to the group. Okay, so I promised we are going to see some past questions. So let me bring them up quickly. I believe you're done writing. I'll need to clean this up. Okay, these ones I'm just going to read them out. I'll read the options, then, you know, give the answers. I will not need to write them. The first one says, the difference between X-rays and gamma ray is? The difference between X-ray and gamma ray is? A says, X-ray are more penetrating than gamma ray. That's A. B says, X-rays are electromagnetic radiations, while gamma ray are negatively charged radiations. That's B. C says, X-ray have higher frequency than gamma ray. Okay. D says, X-ray arise from energy changes in the electronic structure of atoms, while gamma ray comes from the nucleus. Well, you would understand gamma ray better when you do radioactivity. But the answer to this question, A is not the answer to the question. It says X-ray is more penetrating than gamma ray. No. In fact, among the electromagnetic waves, the second to the last is X-ray, and the last is gamma ray. That means gamma, out of all the electromagnetic rays, gamma ray has the highest penetrating power. And you know what that means? That means that gamma ray has the shortest wavelength and has the longest frequency. When I mean by shortest wavelength, see, look at this. This is wavelength, means the distance covered in one cycle. And look at this. You can see that this has a short wavelength, very short, and why this is long. So gamma is actually shorter in wavelength than X-ray. So A is not the answer. B says X-ray are electromagnetic radiations, while gamma rays are negatively charged radiations. That is also not correct, because gamma ray is also an electromagnetic radiation. Both of them are electromagnetic radiations. Okay, C says X-ray have higher frequencies than gamma ray, but that's not true. The one that is short is the one that has the highest frequency. Frequency is another word for speed. That means gamma ray has higher speed than X-ray, okay? Then D is actually the correct answer. The source, X-ray arises from energy changes in the electronic structure of atoms, but gamma ray comes from the nucleus. So the source of X-ray is due to electronic changes in atoms, and the source of gamma ray is from the nucleus. Don't forget that. Okay, let me look for another questions. Or will I say another question? I'm seeing a lot of WAEC questions here for those of you doing WAEC. It says reason to show that X-rays are waves. Reflection, refraction. Uses of X-ray other than medicine. Crystallography, in agriculture, and all of that. And I think that will be it for now. My light is having some issues. Is it clear? It's a little clear, okay? My light is having some issues, so I would have to stop here and we will continue on the WhatsApp group. So you have my number on there. You can just send me a message to join the WhatsApp group. We'll be posting as many questions as possible on the WhatsApp group so that we can practice together. Okay, so at this point, I will say thank you so much. Thank you for joining. Don't forget to share. I will leave this video so that you can go through it again to learn. I wish you the best. Remember, 300, above 300 is the goal. 350, 400. Somebody should give me 400. Okay, so thank you very much. I wish you the best. See you next week, Tuesday. And for those of you interested in joining the JAMB Boost classes, you can send me a message. Thank you. Bye-bye.